Transformations of polynomial functions. So we have transformed functions previously. Now we're going to apply the same transformations with a polynomial. So just a quick review. Remember that f of x can be any parent function. It can be a linear function. It can be an absolute value, a quadratic, a cubic, so on. This is just the basic idea of transformations. So the first thing we're going to talk about is a. What are the changes that happen when a changes? So the first thing is if a is greater than 1, so like a 2 or a 3, even -3, that's why it's absolute value, there's a vertical stretch by a. What that does is it makes the graph narrower. It pulls it top to bottom and makes the graph narrower. If a is less than 1, so like a half or a third or 2/3, it's a vertical compression. So it takes your edges and pushes them together from the top and the bottom and squishes down your function vertically. Finally, if we have a negative a, there's a reflection over the x-axis. So it flips all of your y's from the top part of the graph to the bottom part and the bottom part to the top. So what the value of a does, the value of a will multiply the y values. All the y values will be multiplied by whatever a is, which is what creates the transformations below. B is extremely similar, except B is slightly backwards from A because B affects the x value, it affects the input. So if B is greater than 1, there is a horizontal compression. So now you are compressing in, you're pushing in from left to right and making the graph basically narrower from the outside view. And it's actually a compression by 1 over b. So if b is a2, your horizontal compression is actually by half. If b is less than 1, there is a horizontal stretch. So now you're taking the edges left and right and you're stretching them out, and it's also by 1 over b. So if the b value is 2/3, your horizontal stretch is actually by 3/2. And then finally, if b is negative, there is a reflection over the y-axis. And similarly, the b value will multiply the x values. So a's multiply the y values, b multiplies the x value. Now for C and D. So for the value of C, again, C is directly affecting the input, so C is a little bit backwards as well. If you have x minus c, it's actually a shift to the right by whatever c is. If you have x plus c, it's actually a shift to the left. And what this will do is this will add or subtract your x values. So b and c directly affect the inputs, which is why they're kind of backwards. The value of d affects the y's. So if it's plus a number on the outside, plus d, you will shift up, just like it's supposed to. If it's minus a number, you will shift down. And D actually adds or subtracts the y values. Okay. Now, what kinds of polynomials are we going to be messing with? Well, the first one we're going to be is a cubic parent function. So the equation for the cubic parent function is here, y equals x to the third, and it's kind of an S shape. That's kind of how you can recognize a cubic function. The parent function begins at the bottom left, here, begins here, and ends at the top right. If it doesn't follow those two, that means it's not the parent function. It's still a cubic, it's just not the parent. The other one we're going to be working with is a quartic. So quartic has this equation to the power of 4. Now, if we look at our graph looks extremely similar to a quadratic. However, it's a tad wider here at the bottom. So we have to be careful that we don't accidentally mistake this for a square root function or a quadratic function and not a quartic. Most quartics look like this. If they look like W's. Now, this one does not look like the W because of how simplistic the parent function actually is. This equation is a little bit more complicated in order to get the actual W to form. There is a W here, it's just extremely tiny. So let's do some transformations. So for example 1, describe the transformations of f of x equals x to the third, represented by g of x equals 1/2 negative x plus 5 to the third plus 2, then graph the parent and the transformed function. So the first thing we need to do is identify our parameters, a, b, c, and d. So 1/2 is in the spot where a normally would be, so a is a half. B is here as -1. C would be this, stuck in the middle, so x plus c is what we have. And d is the number added on the outside. And so what do each of these parameters do? Well, a is a half. And if I look at my table, having an a value of 1/2 is an a less than 1. So it means there's going to be a vertical compression by a. So that's our first transformation, vertical compression by 1/2. Then the value of b is a -1. So look at our table. So -1 does not fall in either one of these cases because -1 is equal to a 1. So there isn't a horizontal compression and there's not a horizontal stretch. What there is, though, is the fact that b is a negative. So that means there's a reflection over the y-axis. That's our second transformation. Now, x plus c. This is still affecting the x's, so it's going to be a little bit backwards. So if it's x plus a number, we are shifting to the left by however many c units is. So this will be a shift to left 5 units. And then plus d, plus a number, will shift up by that many. So this will be also go up 2 units. And that's the verbal description of these transformations. Now let's look at the graph. So let's first get the equation and the table for the parent function. So the parent function is here. F of x equals x to the third. So your x's, you can choose whatever you want. However, be careful because eventually you're going to have to take those and go to the third power. So we need to choose x's that are relatively small. So I would start at -2, -1, 0, 1, 2, and 3. To get the values of y, we're going to have to cube our x's. So -2 to the third is -8, -1 to the third is -1, 0 to the third is 0, 1 to the third is 1, 2 to the third is 2, and 3 to the third is 27. Now, for your multiply table has a's and b's. So this is your a and your b parameter. So the a is what affects the y. So since this says 1/2 as a, I'm going to multiply all my y's by half. Now, b affects x, but it's actually 1 over b. So b here is a -1. So if I do 1 over b, that's 1 over -1, which still simplifies to -1. So we're multiplying all of our x's by a -1. Now I'll actually go perform those two operations. So let's start with our x's. So -1 times -2 is a +2. -1 times -1 is 1. 0 times -1 is 0. 1 times -1 is -1. 2 times -1 is -2. 3 times -1 is -3. And now let's do the same thing with the y's. So 1/2 times all of your y's. So -8 times a half is -4. -1 times a half is -0.5. 0 times a half is 0. 1 times a half is 0.5. 8 times a half is 4. And 27 times a half is 13.5. Now for the final transformation is your add and subtract. So this is c and d. So c is what affects the x's, d affects the y's. Well, the y's are the ones that make sense. So since d says +2, we're going to take all of our y's and add 2. C's are the ones that are backwards. So since this says +5, we're actually taking our x's and subtracting 5. So this is the one that's backwards that we have to be careful with. So all of your x's subtract 5. So 2 minus 5 is -3, 1 minus 5 is -4, 0 minus 5 is -5, -6, -7, and -8. On the y's, we're going to add 2 to all of our y's. So -2, 1.5, 2, 2.5, 6, and 15.5. And you have completed the transformations for this first example. The last thing we need to do is actually graph it. Now, the parent function is already here. The parent function is the dashed function. So let's use our final table. This is the one we graph because this is the one table that has all of the transformations applied. So let's go ahead and graph this. So -3, -2, -4, 1.5, -5, 2, -6, 2.5, -7 and 6, And -8 and 15.5, I can't graph. That's too far up. But we have enough to get an idea of what our cubic function should look like. I want you to pause the video, try example number 2. Be careful with your b. Remember that when you do b, it's 1 over whatever b is. Pause the video, try number 2. And here's what you should have had for example number 2. So again, b was a 2, so you need to be careful, and you need to multiply all of your x's by a 1/2 instead of a 2, because it's always 1 over whatever b is. Now let's look at transformations with equations. Let g of x be a vertical stretch by a factor of 2, a horizontal translation right 3 units, and a vertical translation down 3 units from the graph of f of x equals x to the third. So this is the original function we are starting with, and this is also the parent in this case. Now, what are we doing to this? We are going to be, and we're going to take this one by one. There doesn't say an actual order, so we're just going to do it in the order that it shows. So first thing is a vertical stretch by a factor of 2. Well, a vertical stretch is the value of a. So the first transformation we're going to do is we're going to do a times f of x. And I know that a is a 2. So that means we're going to take 2 and multiply the entire original function by 2. So our new function will be y equals 2 times the original function is x to the third. Now, I can simplify a little bit because there's really a 1 in the front of here. So 2 times x to the third is just 2x to the third. So that's my first transformation. The second transformation, it says there was a horizontal translation right 5 units. Well, that is c. So the second transformation is f of x minus c. And since it says we're going to the right 5 units, that means we're going to have x minus 5 on the inside. So what happens is that means this guy replaces x. All of my x's get replaced with x minus 5. That's what c will do. So our old function is here. Y equals 2 times. We are replacing x with x minus 5, because that's the shift to the right, and then to the third power on the outside. Now, x to the third is not that easy to simplify, so we're going to leave this just the way he is for now. And the final transformation, it says, is a vertical translation down 3 units. Well, down 3 units is d. So that's the third transformation, is f of x plus d. So we are taking the function and adding the d value at the end. So what this looks like is this is going to look like f of x minus 3. So we have y equals f of x, which is this function here from step 2, x minus 5 to the third, minus 3. See if you can maybe combine any like terms. Unfortunately, this has an x and the third power, and this does not, so there are no like terms. So this is the transformed function. This guy has a stretch of 2, a shift to the right 5, and a shift down 3. So pause the video, see if you can try example 4 on your own. And here's your result for example number 4. Replace all of your x's with negative x and simplify. Pause the video and try example 5. Example 5 is very similar to example 3, except we're using an x to the 4th power instead of x to the 3rd. Pause the video, try number 5. And here's what you should have had for example 5. Now let's look at example 6. So example 6 is a little bit different because of this phrase followed by that's in here. So for example 6, let the graph of g be a translation 3 units up, followed by a vertical stretch by a factor of 2 of the graph of f of x equals x to the 4th minus 2x squared. Write the equation for g of x. So this is the original, this is where you're starting, and it's not the parent, but that's okay. And the first thing it says that happened was a translation 3 units up. Well, that's the value of d. So the first thing we're going to do is we're going to do f of x plus d. And in this case, it's a up 3, so f of x plus 3. So the original function and then add 3. So we're going to have y equals the original function and then add 3. Now, there's no like terms or anything to combine here, so I can't really simplify this any further. Then it says followed by a vertical stretch by a factor of 2. So vertical stretch by a factor of 2 is the value of a. So it's going to be a times f of x, but I know that a is really a 2. So again, we're going to take 2 and multiply it to the entire function. So y equals 2 times the function that we're transforming is the one we had from the previous step, number 1. And so what happens here is we see that this 2 must be distributed out to everything. And so our function becomes y equals 2x to the 4th minus 4x squared plus 6. So when you have a's, you need to be careful because a is actually applied to the entire function, not just whatever term is in the front. So definitely be careful when you are transforming with the parameter a.